In this example, we are going to be working with the iris dataset. The iris dataset is often referred to as a toy dataset, which basically just means that it is a relatively simple dataset. Nonetheless, this can be a really useful dataset for illustrating various ideas in data science and machine learning. The iris dataset contains information about several flowers from 3 different species of iris. The particular species are called versicolor, setosa, and virginica. For each flower within the dataset, we have 5 pieces of information: the species of the flower, and as well as 4 measurements for various parts of the flower. In particular, each flower contains 2 different leaf-like structures. One is called the sepal and one is called the petal. For each flower, we have a sepal measurement, 2 sepal measurements, and 2 petal measurements. We have the length and the width of the sepal measured across the longest and the widest portions of the sepal. Then we also have the length and width of the petal, again, measured across the longest parts of the petal. So for each flower, we have these 4 measurements as well as the classification of the species of the flower. Now, I'll point out that the original iris dataset contains 150 observations. Just for the sake of this example, I wanted to have a dataset that was a little bit larger, so I actually simulated an additional 450 observations that are somewhat randomly generated, but in such a way as to be similar to the 150 observations that were already within the dataset. So even though the original iris dataset constitutes real-world data, this is a slightly modified version of that iris dataset. Okay, so let's start by loading and exploring the data. So the data is contained in a tab-separated file called data/iris_mod.txt. Okay, so this is the name of the file, and it's stored within the data folder. We're going to use pandas to import this data set into a data frame that we are going to call iris. And then we're going to use the head method to refer to to view the first 10 rows of the data frame. Okay, so here we see 10 individual flowers. For each flower, we have the flower sepal length, sepal width, petal length, petal width, and their species. This one's virginica, setosa, virginica, versicolor, and so on. We can use the Seaborn package to create a pairs plot of the data set. So if I run this code, I get a pairs plot, which is basically consists of all of the different scatter plots that I can form between pairs of variables within this data set. So this will look something like this. Let me make the screen a little bit larger so that we can fit all this on one screen. Okay, so the way to read this pairs plot, if I pick a particular plot, like let's say this one, the x-axis of this plot is petal length. The y-axis of this plot is sepal width. So this is a plot of petal length, sepal width against petal length. And then this, for example, would be a plot of petal length against sepal width. Actually, that's just the flip of the transpose of this plot. So let's take a look at a different one. This one here would be sepal length along the vertical axis and petal width along the horizontal axis. One thing you'll notice from looking at these scatter plots is there seems to be a good deal of separation between my observations. In particular, setosa tends to be fairly well separated from either virginica or versicolor. Now, there does seem to be a little bit of overlap in certain areas between virginica and versicolor, but for the most part, they are also fairly well separated. We also see that perhaps it seems like petal length and petal width are the 2 features for which I get the best separation. That said, we're going to have access to all 4 features in performing our classification. But at the end of the day, what this scatter plot tells me is I should expect my models to actually get a really good accuracy. In fact, they should probably be able to identify the setosa flowers with 100% accuracy and do pretty well on both virginica and versicolor, although there might be a few observations kind of in this middle region where we would expect them not to do that well. So our goal in this exercise is to create a model that reads in these 4 characteristics: sepal length, sepal width, petal length, and petal width as features, and then outputs a single label for Virginica, Setosa, or Versicolor. Now we're going to consider 3 different models in this exercise, one called logistic regression, one called a decision tree algorithm or model, and one called k-nearest neighbors. Again, we're not going to go into the details of how these algorithms work in this lesson. We'll discuss that in future lessons.